going to recap this idea of moving curves around the number plane. So translating curves. A horizontal shift, that's when we replace x with x minus some number. In other words, y becomes function x minus h. Instead of function x, it's x minus h. So we'll move it left or right, depending on whether it's positive or negative, h units. Now, if you're unsure where it gets moved to, the simple way of working it out is solve x minus h equals 0. And that will tell you where it's been shifted to. The vertical shift, well, vertical is to do with range or the y value, so now we replace y with y minus some number. So y minus k is equal to function x. Although we don't normally see it like that, because normally we see our equations as y equals, we normally find the k on the other side. That k can easily be moved over, and it's actually grouped with the y, not with the x. And so that one will shift it up or down k units. And again, if you're unsure, solve y minus k equals 0, and it'll tell you where it's gone. If we have something like this then, so we look at it and we first of all try and identify what basic curve it is, and we see it's y equals and the x is squared. Sure, there's other things happening there, but the y is x squared, so we know the basic curve is our parabola y equals x squared. The question becomes, what have we done to it? Well, grouped with the x, we have this negative 3, so we have shifted it right 3 units, so we'll just move it over there. Then, grouped with the y, we have, well, it's plus 4 on the right hand side, but if it was grouped with the y, it would be y minus 4. So we have shifted it up 4 units. There's our new curve. This one here, well, it is a circle, because I can see the x squared and the y squared. But to work out the shift, I'm going to have to do some completing of the square. So I complete the square on the x squared. We add half the coefficient of x squared, so we square that. Half the coefficient of x in this case is 1, so we add 1 to the right hand side. We also do the same with the y. Half the coefficient of y is negative 2, square that, we get 4. So I'll put 4 on the other side, but I'll also move over that negative 4. So all the constants are on the right hand side, which equals 9. So I now can see it, and I recognise that to be our circle. The basic curve is x squared plus y squared equals 9. So we've got a circle of radius 3 units. We're going to shift it left 1 unit, because grouped with the x, so over we go. Now this one is grouped with the y, so we're shifting it up 2 units. And so there's our new circle. Its centre is at minus 1, 2. Oh, I didn't actually label the radius, I should have done, but the radius would of course be 3 units. Y equals 2x squared plus 8x plus 5. Well, I want it written as x squared. I find that easier to work with when completing squares and things like that. So I'll divide everything by 2. That's the first thing I'm doing there. Now I can complete the square. So add half the coefficient of x, which in this case is 2. Square it, we get 4. Instead of adding it onto the other side, I've subtracted it from the right hand side. It's equivalent to the same thing. The other thing I have to do, because I want y equals, is multiply everything by 2. And there we have it, y equals 2x plus 2 squared minus 3. So again, we're starting with our basic parabola, y equals x squared. What does the 2 do? Well, the 2, if you recall, dilates it or stretches it, depending on how you think about it. This will become a steeper curve. So my parabola, I'm going to make a bit steeper. So it's now 2x squared. The shift, I'm going left 2 units, and I'm going down, in this case, 3 units. There's my new parabola. Then we also looked at things like reflecting curves. So I have vertical reflection. So if I'm reflecting vertically, we're playing with the x values. It's the domain we're playing with. So we replace x with negative x. A function x becomes function negative x. And that will reflect in the y-axis. So we get a vertical reflection. Now you don't have to reflect to the y-axis, you can reflect in any vertical line. So if I want to reflect in the line x equals a, then I would replace x with 2a minus x. Why 2a, not 1a? Well, let me draw a diagram. Here's y equals function x. If I reflect it, I would get function negative x. Remember, we want to reflect actually in the line x equals a. So there's x equals a there. So it has the effect, because of the reflection through A, that origin ends up going to 2A, not A. So that's why it becomes 2A minus x. So function 2a minus x. Horizontally, then we would replace y with negative y, because now it's the range that's changing. So it'd be negative y is equal to function x, or we'd probably more often see it as y equals negative function x. And again, that reflects in the x-axis. If I wanted to reflect in a different horizontal line, same idea. Instead of replacing with negative y, I'll replace with 2a minus y. To draw a picture of that, there's y equals function x. So if the first thing I did was reflect it in the x-axis, but I actually want to reflect it in the line y equals a, again you'll see we actually have to move it up 2a units, not just a units. So we have 2a minus y. Now when you have a combination of reflection and translation, which I did in these two examples there, you'll notice you always do the reflection first. Do the reflection, then translate. Reflection in the origin, or another way of putting that, rotation. That's what rotation is. That's when you make them both negative. So it becomes y equals negative function of negative x. That becomes rotation of 180 degrees. Now you might recognize this y equals negative function negative x. That is our definition for an odd function. And odd functions are the ones that have rotational symmetry. How do we get it? It's those two reflections, one in the x-axis, one in the y-axis. So let's look at that. Here's a random curve y equals function x. The first one I'm doing is reflecting in the x-axis, and we get that particular shape. Now if I reflect to the y-axis, and I get y equals negative function negative x, here's my new shape. Have a look at the first one, have a look at the last one, and you see that actually it's just been rotated 180 degrees effectively. Let's try this. Y equals the negative of x plus 1 cubed plus 2. There's my very dodgy cubic. Y equals x cubed. We always do reflection before translation. So the reflection there is the negative. It's not grouped with the x, it's grouped with the y. So we will reflect in the x-axis. Now we will shift that curve left 1 unit, and finally we'll move it up 2 units. And there's our new graph. Y equals negative 2 to the power of negative x. So both of them have been made negative. There's a negative group with the x and there's a negative group with the y. So this one is our basic exponential 2 to the power of x, but we've reflected in the origin or rotated it 180 degrees. So that would be our new one. Okay, so 3G, playing around with translations and reflections.